So hi guys, welcome to my channel. Today I'm going to explain this question maximum difference which is the GFG POTD problem of the day. It is marked medium. So let's see what question is trying to say and how to approach this problem. By the way, one thing to say that this code is looking big but it's not that big. Like it's very easy to understand. Like once I explain the approach to how to approach this question, now this code will become cakewalk for you. So just bear with me at the end till the end. Okay, so let's start. So given an array a integers, you have to find the maximum absolute difference between the nearest left smaller element and nearest right smaller element of every element in the array. If for any component in the array the nearest smaller element doesn't exist, then consider it as 0. So let's see what it is trying to say. 2487793. 2487793. Okay, so this is the array which is given to us. Now we have to calculate the left part and right part. So for each and every element we have to calculate the smaller element towards left, like nearest smaller element towards nearest left smaller element and nearest right smaller element. So starting from index 2, let's see what is the nearest left smaller element. Going left, it is there is no element present, so we will consider 0 as given in the question. Now we will come to 4. We will start searching towards left. Okay, we got 2 which is less than 4 and it is left, so we will put 2. Now we will come to 8. We will see towards left. Okay, so the 4 is left to it and smaller, so 4. 7. Okay, we will start searching. Again 4 is smaller, we will put 4. For 7, again there is 4. For 9, we'll start searching. It is 7, so we will put 7. For 3, we will start searching. There is no. Here we got the smaller element than 3, so we'll put 3 in our 2 in our element. Now for right, just keep one thing in mind, that to calculate the left, we are calculate from the entire left to see that whether there is any element present at the left of this. Now to calculate the right, we will start from the right to see that whether any element present at the right or not, which is smaller than 3. So there is no element, so we will consider it as 0. Now coming to 9, you can see that the nearest smaller left element is 3. We will put 3. Again 7, 9 is bigger, so 3. Again 7, then 3. 8. Nearest smaller towards 8, nearest smaller to 8, which is right to 8 is 7. Put 7. Nearest smaller right of 4 is 3. We'll put 3. And for 2, there is no element, so we'll put 0. Okay. Now at the end, what we will have to do is, we have to find the maximum absolute difference between the left smaller element, right smaller element. So we'll take the absolute difference, which is 2. 7 minus 3 is 4. 4 minus 3 is 1. 1, 3, 1 and 0. So we have to find the maximum difference. So maximum difference is 4. So our answer is 4. As you can see that the output is 4 and it came from the ABS of 7 minus 3. ABS of 7 minus 3. Okay. So let's see how we can calculate the left vector and right vector, because if we calculate the left vector and right vector, then calculating the maximum difference is like cakewalk. So now the optimal approach to find the nearest left smaller element and right smaller element is to use the stack. Why I'm saying? Because we have to calculate for every element, and if for every element we will start searching towards left, then again start searching towards left, then start searching towards left, then it will be not optimal. It will be big of n square, which is like big of n square for this and big of n square for this, and in constraint we are given that we have to use big of n times, so we'll take the help of stack. Now how stack will help us, let's see. I take this to the left side so as to explain why and how stack will be helping us to calculate the next smaller element. I'll be explaining the by doing the right run or left array. Okay, and right array is very similar to the left array. Everything is similar except one thing which I have already told you in the starting, that for left array we will starting from the 0th index, and for right array we will starting from the end of that right index, right array, like whatever arrays. So at the beginning this is the stack. Okay, so how we calculate? Okay, this is typo, stack. So now at the very beginning, if the stack is empty, we will put 0 in the left array, and we will put, like from here we have started traversing, like for 2 we'll check if the stack is empty. Yes, the stack is empty, we'll put 0 in our answer, and at last we'll put 2. Now the pointer comes to this 4. Let's see. Okay, this 4. So we will check the stack from the top, like if stack is empty, no, stack is not empty, stack, there is element present in the stack. We'll check if stack top is less than 4. Okay, yes, stack top is less than 4, then we will directly put 2 in our answer, and we will insert 4 in the stack. Now here comes the turn of 8. We'll check if stack is empty. No, stack is not empty, there are elements in the stack. We'll check if stack top is less than 8. Yes, stack top is less than 8, so we will put 4 in our answer. Now we'll insert 8. We'll go to 7. Now if we'll check, now it's turn of 7. If stack is empty, no, stack is not empty, there are elements in the stack. Stack top is less than 7, no. Then we will perform some operations. What operations we'll perform? We will pop the elements from the stack until and unless the stack becomes empty, or we get the stack top which is less than array of I. Until and unless both, like any of the two conditions fulfill, we will pop the elements. So we will pop 8 from the stack and again check, like if stack top is less than 7, yes, this condition meet, so we will come out of the loop and print 4 to our answer left, and put next element after inserting 7. Again check for 7. Okay, stack top, is it smaller than 7? No, it is not smaller than 7, so we will put the pop operations and see. Now 4 is smaller than 7, we will again push 4. Now insert 7. Now we will see for 9. We can see that stack top, if 7 is less than 9, yes, 7 is less than 9, so we will put 7 in our answer and insert 9. Now there is the term called 3. It's 3 is done, so we'll check at the stack top, like if 9 is smaller than 3, no, we'll pop. 7 is smaller than 3, no. 4 is smaller than 3, no. 2 is smaller than 3, yes, so this condition met, so we will put 2. What if this condition also not met? So stack would have become empty, and if at the condition of empty, we will push 0 to our answer. But here the condition doesn't match. Like for the left array we have pushed the element, so 0 we have pushed, 2, 4, 4, 4, 7, 2. This looks same as this. Okay, why I have written again? Because for the right array we will start traversing from the 3, so we would have pushed 0, then 3, then 3, then 3, then 7, then 3, then 0, which is the reverse of this array, because we have start from the ending. So while calculating the right array at the end, you would have to reverse the right array, so that it would look like this. Okay, rest everything is same as we have calculated the left array. So let's move to the code to see. Now what I have done is I have created 2 vectors, left and right. I have calculated smaller to left and passed the left array, smaller to right, passed the right array. I have initialized a variable with int min, so I can get the maximum value. So calculating the traversing the left or right, or say array dot size, arr dot size, and ABS of let, every time I am calculating the difference between left and right, its absolute value, and storing it in the maximum value. And after all, we are returning the maximum value. Let's move to smaller to right. I have created a stack. Now what I have told, For calculating the right array, I will start from the end. So it is like array dot size minus 1, means whatever array of the dot size minus 1, because 0 based indexing. Now if stack is empty, what I have said, if stack is empty, like there is no element, then we'll consider 0. We have pushed 0 to our right vector. If stack top is, if our stack is not empty, then what we are doing, if stack, we will check the next condition. If stack top is less than array of I, means we are searching at the stack top, this one. If after looking from the right side we get the left smaller element than the current array of element, then we will put stack top in our answer. Then we have pushed stack top in our answer. Else if stack top is greater than array of I, like if we get the element, whatever element x, y, which is greater than 3, so we will start popping out elements. So while stack size is greater than 0, or if we, or else we can write that while not st dot empty, then jab tak, means until and unless stack is not empty and stack top is greater than array of I, we will start popping out elements. If this while conditions, coming out from the while condition, there is two possibility. If the stack is becomes empty, or stack top is less than. If stack becomes empty, then we'll put 0, as I have told you that if this would have been also gone, then we'll be putting 0 to our left answer. Else this stack, we have get the element which is smaller than the array of I, so we'll put the stack top. Like in this case, after popping the elements, we got the element which is smaller than 3, so we have pushed 3 to our answer. Now at last, for calculating the reverse right part, what I have said, for calculating from the end of the array elements, we will reverse it. So I have done reverse right dot begin and right dot end. Similarly, I am calculating the left vector, like smaller to left, calculating from 0 to array of size, everything is same. Stack, if stack is empty, push 0. Else if stack top is smaller than array of I, then push the stack top. Else if stack top is greater than array of I, then pop the elements from the stack until and unless you get the smaller element on the stack top which is less than array of I. If stack becomes empty while performing the pop operations, you will come out of the loop and check. If the stack becomes empty, then you will put left, like 0 to the left, and else you will put stack top to the left. Then at last we are inserting the whatever positions we are standing in the array, we are inserting this in the stack top at the last position. Like here we also doing same, and here also we are doing same, but on the left, while calculating the left part, we are starting from here, so we have pushed the right elements on the right index, so there is no need to perform the reverse operation. But for right, calculating the right vector, we have to perform the reverse operation, and finally we are returning the maxi. So let's run, and it got submitted. Submit. So I hope this question is very clear to you, and I feel that now you will be like, this code has become cakewalk for you. So thank you for watching this. Thank you.